All right, so I am literally in mad scientist mode now. I'm doing several things at once. I have installed the SPV wallet implementation, which is really just an infrastructure that you build out. And for example, it's written in Go, from what I can tell. And then this application that I built on top of it, which is just to demo how Bitcoin is a circuit. This is built with the BSV TypeScript SDK. So that's the lab going on here. And then what I'm exploring now is how this SPV wallet works. So I can show you. Let's see. Okay, this is actually the application that I built that uses the wallet infrastructure. So let me show you. Okay, so this is basically the SPV wallet admin, and this is what ships. I didn't build any of this front end. This is all built by BSV architects, probably from the BSVA. What we're looking at is what you would have as an admin if you were an application developer that utilized their wallet. I'm exploring the paymail. So I have, a paymail for Alice, and I used ngrok. So I'm using free ngrok. So that means that this paymail, Alice could no longer receive money at this if my ngrok tunnel is expired. I think it's still going. Doesn't matter. This is all just for play. Now, the first time I played with my application that I built. So this guy, when I generated keys, let's do this. So I just generated a key for Alice, who is theoretically a person using this application I'm building. I'm going to register with the wallet. Alice has 0 Satoshis, but if we go over to the wallet admin, we should have a second entry in the xPub, and we do. It's the one that just happened with the 0 balance. All right, so I'm having a conversation with Claude, but I'm getting pretty deep, right? So I'm wanting it to look inside code so that I can understand things. And this is what I encourage you to do. Not just, quote vibe code out stuff, but really understand what these SDKs, and in this case, what this wallet infrastructure implementation, so not an SDK per se, but what this wallet infrastructure is doing. So the question I'm asking here is about the SPV part. So I saw that they use beef, and so I'm asking it to look into this. So let's, now I'm going to allow it to look. Here I'm talking about the SQLite database. Because I use the SQLite in their implementation, and they use Docker, the way it's implemented is that it does not keep the SQLite data outside of the Docker install. So it lost essentially my SQLite data. And so I had to create an installation that has a container on its own. And then so what I had to do was add a Docker volume called SPV Wallet Data. And this is persistent storage that lives outside the container. Now, I think that what they would tell you is to use a Postgres SQL when you answer the install questions, which I did not because I was just playing. So I wouldn't say that this is a flaw. I would say that it is just me kind of messing around and having to do stuff in figuring out the scene, though I think it is worth noting that that is the case. So you see, we did add a Docker volume called SPV Wallet data, and this is persistent. So now I'll go back. SPV Wallet, let's see, where is it? Container. Admin, backend, header service, front end. I don't know, we're checking to see if the database is in there. Yeah, there it is, spvwallet.db. So the file survives Docker compose down. Okay, that's good. All right, so we were looking at Beef SPV implementation and the database schema, and here's what the code shows. Beef storage is smart. The wallet doesn't always store the full beef. It makes a decision per transaction. If all input source transactions are already in the database, it stores just the raw hex plus links to the source transactions, which saves space. If some ancestors, that means, what was the coin that spent the current coin? That's what we mean by ancestors. If some ancestors are missing from the database, it stores the full beef hex. Your incoming transaction from Handcash, that's what I did last night. It was stored as beef because that was an external transaction. Yes, that's something I ran into in a different build I was doing where it was maddening. I didn't quite understand how that works. Okay. The wallet didn't have the source transactions in its database. Okay, so now when a transaction gets mined, Arc calls back and the wallet updates the record. So Arc is, the communication between the chain and your application for broadcasting and callbacks, meaning did this transaction hit the chain? TX with either beef hex or raw hex block info. What block was it in? And status. Stores ancestry links. I'm assuming the block info is, of course, that has the Merkle root, because that's how this all ties into the block header service, which is that very small amount of information that you need to carry, which allows you to prove the SPV part. It allows you to prove that a transaction was in a block without having to have the whole blockchain. So let's see. It stores user UTXO. Okay, so these are the different tables. User UTXO, operation, data, user address, paymail. That's what I was talking about before. So it stores alias domain. That's that ngrok domain that I used, which will get trashed, but at least it allows me to recreate a private key. The system does, so that I can spend those coins even though my ngrok domain is trashed. Query the actual SQLite database. I absolutely do. Yes, please. Now it's frolicking. I love the terms that Claude uses in terminal. So let's see, what are we going to do here? So it's looking in that SQLite database, OCI runtime. No SQLite in the container. Yeah, it's not in the container because we brought it outside the container. Yeah, I do. So it copied the data. That's the V1 schema. Let me look at what's in each table. Now we're looking at the actual transaction with its beef data. So it's only one transaction that I did. And that transaction was I sent from Handcash to the paymail that I created using this SPV wallet architecture. So here you can see we're looking in the database. All right. This was the transaction. It was mined in block height 934, 954. 2 inputs and 2 outputs, total value 200,000 sats. Alice's output, this is what Alice got when I sent 2 pennies, 2 US cents, to her paymail address in this system. So the Merkle, the destination, this is the address that was derived from Alice's xPub. That's what's here. So let me go here. In this system, these are the xPubs. It doesn't give the name here. It's just the xPubs. So, which is not an address. It is what an address gets derived from in this system. All right. So Alice has 1 unspent output, meaning it hasn't been spent yet, correct? So spending TXID is empty. The destination, this is the address that was derived, yeah, that's where we were, from Alice's xPub when Handcash requested a payment destination. The Merkle proof, this is the bump. That bump field is the full Merkle path. So, walking up the Merkle tree to get to the Merkle root, so we tie the unique transaction to its block. 9 levels deep, proving this transaction is in block 934, 954. Metadata sender was Bridget33 at handcash.io. Handcash's server reference ID that links back to the P2P payment destination request. This is the V1 schema. So the hex column stores the raw transaction hex, not beef. The Merkle proof is stored separately in the bump column. The V2 schema we looked at earlier in the code would store things differently. All right, so this is key. So earlier, it couldn't look directly at my code, so it went out and checked reference docs. And so what I have installed is V1, which is not beef. Really could store things differently, but you're running instances using the V1 tables. So where I installed this from, so it doesn't use beef if you just install it out of the box. So let's see. The setup flow is what we already did. Git clone cd SPV wallet. Yeah, the start.sh. And then that script that I went through, you chose. It says we chose. It wasn't involved in this. I chose it, but let's see. Admin keys. Yep. I used the defaults. Paymail domain, where to receive transactions. I set I don't know why it's claiming that it did all this stuff. Maybe it's just looking at my code, but it wasn't involved in this process. Some of it. Where to receive transactions. Yep, we set that ngrok domain. And I decided to disable traffic and used, because that's more for like a public implementation. I just wanted to get it done and cheaply. Cheap meaning free. Okay, port layout matches. So what we're looking at here is what you get when you use that SPV wallet. Let's see if this is the URL that I started from. This is all true. This is exactly what the process I went through. Tested all of these localhost ports. And they all work. Built a new one, this Bitcoin validation circuit. You can see This is when I installed the BSV SDK for TypeScript. Interesting thing, the guide mentions that for public exposure, you need A records. Yes, you would need to set in your domain an A record for public exposure. Let's see. And yes, DNSSEC protection. We did bypass all of that because we used ngrok. So our setup is functionally equivalent to what the guide describes with the SQLite plus free cache learning profile, meaning, let's see, an ngrok replacing the traffic DNS approach for public access. Yeah. The main difference is we also added this is what we did last night. We added the persistent volume mount for SQLite, which the guide doesn't explicitly call out. Their default keeps the DB inside the container. So I'm curious why it would do that. And because what we found is that it certainly trashed all of my data when we restarted the container. So why would they do that architecturally? I don't quite understand. So the two database options have different philosophies. Postgres, you care about your data. SQLite, you're playing around. So this is arguably a bad default. As we discovered, it's very easy to register users, create paymails, even receive a real BSV, and then lose everything on a Docker Compose down. There's no warning in the UI or the start script that says, hey, your SQLite data will vanish. Bottom line, they optimize for a clean slate demo experience over data safety, assuming anyone serious would pick Postgres. That's a reasonable default for a developer tool, but it should come with a bigger warning label. I would agree. I mean, it's all fine. I didn't lose any coin at all because I was watching it as I did it and trying, I'm very careful. So, but not everyone is careful. All right, maybe that is enough for today.
Got a curve in the game, laid out clean with the point named G and a math machine. Pick a secret number, that's your key. Multiply G, now the public can see. On the curve, can't fake what you saw.